This is the overview on the refrigeration cycle of our ice machine. We start from here. We've got a compressor, we've got a condensing unit, a liquid receiver, filter dryer, a heat exchange, TXV valve, and an evaporator. What I want to focus on first is, if you have a look here, there is a hot valve pipe. So what I'm going to do is I'm just going to get rid of this for now, so we don't confuse the cycle. If we go back to the compressor, the refrigerant gets pumped through, goes to the condensing unit, cools down, and goes to the liquid receiver, to the filter dryer, through the heat exchange, to the TXV valve, and from the TXV it squirts out and it cools down the actual evaporator. This evaporator section here, that's where your actual ice cube tray is bolted onto that. But we'll discuss that in the next lecture. So following the components, compressor, as we mentioned in the domestic and the light commercial, the concepts have changed. Only thing that's changed right now is we have a liquid receiver and we've got a TXV valve. On domestic, you'll have a capillary tube instead of the TXV valve. The purpose of this liquid receiver is because we're using a TXV valve, and this opens and closes a little valve each time the sensing valve detects too much liquid. This liquid receiver will ease off the pressure off the actual circulation system, which will be explained in the commercial course in further detail. So as my cycle goes through, as we see, the refrigerant goes through, cools down, freezes up the evaporator, and returns to the actual compressor and repeats the cycle. Now in the instance where the ice machine is going to go into defrost, what happens here is this valve gets activated through the electronic circuit, and if we have a look here, you have your gas running through, or your refrigerant running through, but also what it does is opens up this part here and it enters the evaporator with hot refrigerant, and it starts to melt the ice on the tray. As this heats up, the ice starts melting, and it'll eventually will slip off the ice cube tray and into the bucket and bin. After so many minutes, what happens is the hot valve turns off, and there will be a sensor which we'll describe in the next lecture to tell the machine to go back into the freezing mode. So what that happens is the valve will turn off, and then what happens is, let's just erase this. With this valve turned off, the refrigerant moves through the system again, through the condenser and through the TXV valve, and it'll start cooling the ice cube evaporator once again. And the cycle will just repeat itself over and over again. These principles will be very similar on different types of ice machine manufacturers. All that will change is the basic operations. For instance, some will have certain sensors scattered across the circuit, which will be linked to a PC board. Just to recap, in a freezing cycle, hot gas gets pushed through. It won't go through the hot valve because it's going to be in a freeze cycle. Runs through my condenser to the liquid receiver, through the system, and cools down the evaporator and returns. As soon as it's time for defrost, all that's going to happen is my hot valve is going to turn on, and like I explained, it's going to heat up the evaporator unit. And if we follow this line, although I'm getting some refrigerant running through the system, the majority of my heat will be coming through the hot valve. So you'll see the two different pressures meeting at one point. This one will come through the TXV, but this one is always after the TXV valve because we're getting direct heat, which is going before the condensing unit. And if you remember, the condensing unit's purpose is to cool down the refrigerant. Here we're coming straight out of the compressor through the TXV valve, heats this up, and returns into the system.